Bob is riding his bicycle along the same path. For 0 is less than or equal to t is less than or equal to 10, Bob's velocity is modeled by b of t is equal to t to the third minus 6t squared plus 300, where t is measured in minutes and b of t is measured in meters per minute. Find Bob's acceleration at time t equals 5. Well, acceleration, this is a velocity function right over here. So the acceleration is going to be the derivative of the velocity function with respect to time. What is the rate of change of velocity with respect to time? That's acceleration. So we really just want to evaluate Bob's acceleration at t equals 5. That's going to be b prime of 5. So let's first figure out what b prime of t is. B prime of t is equal to, we'll take the derivative here. It's pretty straightforward. Just use the power rule. So it's going to be 3t squared minus 12t. 2 times negative 6 is 12, or negative 12. And then the derivative of 300. 300 doesn't change with respect to time, so it's just 0. And so b prime of 5 is going to be equal to 3 times 5 squared minus 12 times 5, which is equal to 75 minus 60, which is equal to 15. And the units here, this is acceleration. So this is going to be, his velocity was in meters per minute. And so this is going to be meters per minute, because remember, time is in terms of minutes. So we could write as meters, let me write it out, meters per minute, which is the same thing as meters per minute squared. All right, let's do the next part. Based on the model B from part C, find Bob's average velocity during the interval from 0 is less than or equal to t is less than or equal to 10. And if the notion of average velocity or average value of a function is completely foreign to you, I encourage you to watch the videos on Khan Academy on finding the average of a function. But just to kind of cut to the chase, the average velocity is going to be the area under the velocity curve divided by our change in time. So the area under the velocity curve from t equals 0 to t equals 10 of b of t dt divided by our change in time. So it's going to be divided by, well, you're going from 0 to 10. So 10 minus 0 is going to be equal to 10. And if you wanted the intuition here, it's like, well, if you know the area of something and if you wanted to find its average height, you could just divide by its width. And that's what we're doing here. If we know the area of something, we want to figure out its average height, and so you divide by its width. That's, I guess, a very high-level intuition for where this expression came from. And so this is going to be equal to 1/10 times the integral from 0 to 10. And b of t is t to the third power minus 6t squared plus 300 dt. And so this is going to be equal to 1 over 10. Take the antiderivative here, so this is going to be t to the fourth over 4, t to the fourth over 4. And then this is going to be, if we increase the exponent here by 1, is t to the third, and then you divide by 3. So it's negative 6 divided by 3 is negative 2 t to the third. And then plus 300t, and I'm going to evaluate it. I am going to evaluate it at 10 and subtract from that it evaluated at 0. And so this is going to be equal to, 1/10, that same 1/10 there. And when you evaluate all of this at 10, what are we going to get? Let's see, 10 to the fourth power is 10,000 divided by 4 is 2,500. And then minus 2 times 10 to the third. So it's 2 times 1,000. So minus 2,000. And then 300 times 10, well, that's plus 3,000. And then you subtract all of this evaluated at 0, which is just going to be 0. So this is going to be equal to 2,500 minus 2,000 is 500 plus 3,000. This is all simplifies to 3,500 or 3,500, and then you divide it by 10. This is going to be 350, and it's an average velocity, meters per 350 meters per minute. And we are done.